Hello everyone, my name is Akanksha Sharma and welcome back to my YouTube channel. So, in the series of electronic displacement in covalent bonds, I am back with another video. In the previous video, as you already know, that we have studied about the electromeric effect in detail, its types and also its examples. So now, in this video, I am going to teach you inductive effect, why it is used in the organic chemistry, what are the various types of inductive effect, and also the applications of inductive effect. So without wasting any time, let's get started. So we have studied that there are two types of effect. Those are temporary effect and permanent effect. Temporary effect was electromeric effect and inductive effect is a permanent effect. It takes place through sigma bond. That means it does not take place through any pi bond. So what is inductive effect? It is the partial electron transfer that occurs when either more electronegative, it means electronegative, either more electronegative or less electronegative atom is attached to the carbon atom. Here you can see an atom Z. I have denoted any electronegative atom as Z. It is less electronegative. If it is less electronegative, it will release its electrons towards the carbon chain. And here, if Z is more electronegative, it will withdraw electrons from the carbon chain. Okay, so inductive effect is distance dependent. It depends on the distance from the source. If the distance from the source increases, if the distance increases, then intensity of inductive effect decreases. Here, chlorine atom is attached to the carbon. This carbon is very far from the chlorine. So here on this carbon, inductive effect is very less than the first carbon. Okay. Also inductive effect, as we know that it is distance dependent. So it is only applicable up to 4 carbon atoms. After 4 carbon atoms, its effect gradually decreases and also after some time it vanishes completely. Now, I hope the concept of inductive effect is very clear to all of you. Now, the types of inductive effect, it is of two types, that is plus I effect and minus I effect. So what is plus I effect? Whenever any electron releasing group is attached to the carbon atom, then it shows the plus I effect. Here you can see electron releasing group is attached to the carbon atom. It releases electrons. Okay. Here is the example. CH3 group is electron releasing group. Here it is a tertiary butyl. Tertiary butyl means 3 CH3 groups are attached to the carbon. So electron density will be maximum at this carbon due to the electron releasing effect of this CH3 group. Plus I effect of tertiary butyl is maximum as compared to secondary propyl because only 2 CH3 groups are attached to the carbon. After that, ethyl group has lesser plus I effect as compared to this and this, and then after that methyl group has very less plus I effect. More substituted alkyl group has strongest plus I effect. As you can see, it is more substituted. Three alkyl groups are attached to this carbon. So it will show strongest plus I effect. Now, minus I effect. Whenever any electron withdrawing group is attached to the carbon, then it will show minus I effect. See, here is the order, decreasing order of some groups that are electron withdrawing in nature. First of all, the maximum electron withdrawing nature group is NO2, that is nitro group has maximum electron withdrawing nature and it shows maximum minus I effect. After that, cyanide group CN, COOH, carboxylic acid group COOR. Then after that, all the halogens, fluorine, chlorine, bromine, iodine. Then after that, OH, OCH3, C6H5 phenyl group and hydrogen. This has least minus I effect. So these are the types of Inductive effect, plus I effect, and minus I effect. Plus I effect when electron releasing group is attached to the carbon, and minus I effect when electron withdrawing group is attached to the carbon. Now, let's move forward towards the applications of inductive effect. So what are the applications? Where it is used? Why we use inductive effect? So first of all, let us know about some facts. That is, if minus I effect increases, then bond angle decreases. Okay. As we have studied in this series, that fluorine has maximum minus I effect as compared to chlorine, as compared to bromine, and as compared to iodine. So, as fluorine is showing maximum minus I effect among this, and this, so its bond length will be smaller. See, 1.38 angstrom its bond length. Its bond length is 1.94 angstrom and it is 2.4 angstrom. So, here it is clear that if minus I effect increases, then bond length decreases. Next, if minus I effect increases, then dipole moment also increases. What is dipole moment? First of all, this question arises into our mind. In simple words, dipole moment, look at this word dipole, means two different poles. That means a less electronegative atom and more electronegative atom. The charge separation between these two atoms is dipole. See, as we know that electronegativity difference, fluorine, chlorine, bromine and iodine. Fluorine is most electronegative atom in the whole periodic table. Down the group, electronegativity decreases. So, in this case, chlorine is most electronegative as compared to bromine and then iodine. So, it has more dipole moment because charge separation. Carbon is electropositive and chlorine is electronegative. Okay, so it shows maximum dipole moment. More dipole moment, more inductive effect. And in this, less dipole moment, so less inductive effect. In this order, dipole moment decreases. Okay. Then after that, reactivity of alkyl halides. With more branching, reactivity increases due to increase in CX bond polarity. That means, look here carbon is more branched. 3 alkyl groups are attached to the carbon. They will release electrons. Okay, because CH3 is a electron releasing group. We have studied here. CH3 is a electron releasing group. It is electron releasing and it is halogen, that is electron withdrawing. It will be satisfied after gaining all the electrons. So reactivity of alkyl halide, this has maximum reactivity and this is less branched as compared to this. It will also release electrons. Less reactivity as compared to this, and after that this has lesser reactivity as compared to both of them. So next, relative strengths of organic acids. All these are acids. Okay, all these are acids. Here I have already written that this is more acidic as compared to this and as compared to this, because as we know, fluorine has maximum electron withdrawing nature. See here, this has maximum electron withdrawing nature as compared to all the halogens. So fluorine will withdraw the electrons towards itself. It will go like this. This will not donate electron because this is a pi bond. Inductive effect takes place only through the sigma bonds. And here, chlorine is also electron withdrawing in nature. It will withdraw electrons like this. Also, bromine will also withdraw the electrons. So minus I effect decreases, acidic strength also decreases. Okay, so minus I effect is directly proportional to acidic strength. Next, another example. This is the trichloroacetic acid. Here, look. 3 chlorine atoms are attached. It will also withdraw electrons, it will also withdraw electrons, and it will also withdraw electrons. Like this, and like this. Okay. Here, 2 chlorine atoms are attached. They will withdraw the electrons. It will go like this. Okay. It is a dichloroacetic acid. So here we can conclude that 3 chlorine atoms are attached. That means it is more branched. So it will have maximum minus I effect, and also its acidic strength will be more. Here see, hydrogen will give all its electrons and it will be easily out. So acidic strength is also our proton releasing tendency. It will easily release the proton from its structure. So it will be more acidic. It will also release the proton from its structure, but less easily than this. Okay. Now here a question arises, which is more basic, ammonia or ethylamine? First of all, we need to know that what is basic strength. Here basic strength means the electron releasing tendency. Here I am writing electron releasing tendency. From the electron pair present on nitrogen atom in both the structures. So here ethyl group is electron releasing in nature. It will release its electrons towards the nitrogen. Nitrogen will become electron rich and it will have more electron releasing tendency. It will donate its electron very easily as compared to this. So this is more basic. Ethylamine is more basic than ammonia due to plus I effect of ethyl group. Now again a question arises, which is more basic, aniline or ethylamine? So in aniline, this is a phenyl group. Phenyl group is attached to the NH2. It will have minus I effect. Here we have studied phenyl group. It is last in this order. So it will have least minus I effect. It will show least minus I effect as compared to C2H5. C2H5 is electron releasing in nature. It will release its electron releasing group. Again the same concept is applied. It is electron releasing, plus I effect increases. So electron density increases on this nitrogen and it will easily donate its electrons. That leads to basic strength. And in this, due to minus I effect of aniline, it is withdrawing electrons towards itself from nitrogen atom and it will delocalize all the electrons in its benzene ring. So this is less basic as compared to ethylamine. So this was all about inductive effect. I hope now you don't have any problem in the inductive effect. It is a very basic topic of organic chemistry. You need to know about this topic. So if you like this video, please do comment and also share this video with your friends. I will make more such videos. So for that, subscribe to my YouTube channel and also press the bell icon. Thanks for watching.